In this experiment, we'll look into the method of measuring the specific capacity of water. Let's watch the movie clip of this experiment first. We may also look at the animation. It shows how can we find the specific capacity of water. Now let's look at example 5. In this example, we have done an experiment to find the specific capacity of water, and we have collected some data. Say mass of water is 0.2 kg. Initial geometry reading is 46,000 J. That means at the beginning the reading is 46,000. Final geometry reading is 61,000 J. That means at the end the reading on the geometer is 61,000. The initial temperature of the water is 20 degrees Celsius and the final temperature is 37 degrees Celsius. A1. It asks us how much energy is used to heat up the water. Well, we can just check on the reading of the geometer. In fact, the difference between the final geometer reading and the initial geometer reading is the energy used up. That means we just find the difference of 61,000 and 46,000, which equals to 15,000 J. A2, what is the temperature change? And we can find the reading shown on the thermometer. So the difference between the final temperature and the initial temperature is the answer. And it equals to 17 degrees Celsius. A3, find the specific capacity of the water. So first of all, we have to recall the equation of specific heat capacity of the water. In this equation, C is the unknown. E is the energy used. We have find it in A1. M is the mass of the water, which is given as 0.2 kg. Delta is the temperature change, and we have found it in A2. In other words, after we put all the values into the equation, we can get the specific capacity of the water. And the answer is 4,410 J per kg per degree Celsius. Part B. State one possible source of errors in this experiment. Well, in this case, even we use polystyrene cup to do this experiment, energy is still lost to the surroundings. By the way, some energy is also lost to the stirrer, thermometer, and the polystyrene cup. Part C, it says, the measured value obtained in A3 is higher than the real value. Well, the measured value is 4,410 and the real value is 4,200. So the measured value is a bit higher. Then the question asks us, why? In this case, energy is lost to the surroundings. So compared to an ideal experiment, we need extra, or you may say additional, energy to heat up the water. So when we use more energy, then the calculated specific heat capacity becomes larger than the real value. To get more information, you may look at HKCE 208, Paper 1, Question 4. It's a question about specific capacity.